11, and A1000 is 11 plus 999 fives. Which is 4,995. Oh,
Plus
1,005 subtract 5
Plus 11.
plus 11. $4,995 plus 11. 5,006. So the answer here is 5,006 plus 11 divided by 2 times 1,000. No, 5,006 plus 11 is
We already had it.
what?
We already had it.
That's to get one A1000.
Oh, yeah, you're right.
And you can take the average of the first term and the last term and multiply by 1,000. What is the calculator? What is that number, Miss Jasmina? I'm sorry?
2 million.
2 billion.
2 million.
2 million. That's a huge number, no doubt. 2,
2 million.
2, 0, 0. Well, you go home and do it. Okay? Now, who thinks I can add infinitely many terms of an arithmetic sequence and get a finite number? Raise your hand. Who thinks it depends? Raise your hand. Who thinks it's always infinity or negative infinity? Raise your hand. Because you're always adding the same common difference. 5 plus 5 plus 5 plus 5 plus 5 plus 5. You will get to Kennesaw, then you will get to California, and then you will get to Guam, Pacific, and then you will get to Mercury, and then you will get to Alpha Centauri. You just keep adding 5s. Of course, if you subtract 5s, it will go the other way. You just keep subtracting 5. No matter where you start, when you start at 10 billion, eventually you'll get down to 0. And then you'll be going negative. So you can never add infinitely many terms of an arithmetic sequence and get something that is fine. Okay. An arithmetic sequence something like this. Give me an arithmetic sequence. A1 plus I minus 1d, is that correct? Now, this does not depend on I, so you just add them up. Oh, like this one here. What's the first term? 11. Yes. When I is 1, this is 0. And this is 11. I is now 2. This is
11 plus 5 is
16. I is now 3. This is 21. I is now 4. This is
26.
You get me? If you think you're going to get a finite number, you don't have a prayer. Huh? It's going to be infinite. What if you have a negative number? Well, then you're just going to go to negative infinity. So here's the arithmetic sequence. What's my common difference? Negative 1/2. And my first term? 5. So my sequence is what? And the next one?
4.
And the next one? And the next one? And the next one? And if I add these all up, what do you think I'm going to get? Negative infinity. Because I'm just subtracting half and adding, subtracting half and adding, subtracting half and adding. You'll see, I'm just going to be adding too many negatives now. Contra negative infinity. So an arithmetic series never converges. Never. And that is all I have to say about arithmetic sequences. More than that, you will have to ask your pre-calculus professor. And the next type of sequence you want is one that you have also seen in pre-calculus. That is to say, if you take an exponential function and evaluate them as integers. Right? What are arithmetic sequences? You take linear functions, and you evaluate them at the integers. Did I tell you that last time? Arithmetic sequences are just lines where you evaluate them at the integers. Well, here's a negative common difference. And here's a positive common difference. Depends on the slope. Slope of 3 is the common difference. If the slope was negative 2/3, the common difference would be negative 2/3. Now we're going to take exponential functions and evaluate them at the integers. We're going to pick up what sequences? Geometric sequences. Geometric sequences. Again, you will need to tell me two things. You will need to tell me how to build a sequence up. You will need to tell me the first term, and you will need to tell me, well, how do you get the next one? That is to say, what is the common ratio? All right, arithmetic sequence, when you go from here to here, you add the slope. 3, 3, 3. on a geometric sequence, you say, take this one and multiply by 3, take that one and multiply by 3, take that one and multiply by 3, take that one and multiply by 3. Multiply by the common ratio. You will need to tell me your first term, and you will need to tell me the common ratio, and then you will work it out. So A5 will be A4 times the common ratio, which would be A3 times A4 would be A3 times the common ratio, but A3 is A2 times the common ratio, and A2 is A1 times the common ratio, and well, there you go. A4 is what? A1R cubed. So AI is what? A1 times R to the power I minus 1. I think you would have seen that in pre-calculus. Yes, Mr. Tyler?
Yes.
If we have a first term of 4 and a common ratio of 3, then A1 is 4 and A2 is what? 4 times 3, which is 12. And what is A3? 4 squared times 3 squared times 4 times 3 squared. What is A4? 4 times 3 cubed. What is A5? 4 times 3, 4. This one is 3 times that.